Now we're going to use our slope formula to find the slope given 2 points. We're also going to show you that we can graph that and get the same value for the slope either way. So when I'm trying to use the slope formula, which I put here at the top as a reminder from the previous page, the first thing I want to do is label my points x1, y1, x2, y2. So the 1 and the 2 are just like saying, hi, I'm the first x, or hi, I'm the second x. And then when I plug it into my formula, y2 minus y1 over x2 minus x1, notice that there's already minuses in the formula. Okay, those come from the formula. So when I'm plugging in y2, which is 2, then there's a minus because there's a minus from the formula, y1, which happens to be negative 4. So the negative in the red comes from the negative 4. The purple negative comes from my actual formula. Over x2, which happens to be negative 4, minus because there's a minus from my formula, 6. So when I reduce this, minus a negative, that's add a line, change the sign, that's actually a positive 6, over 2 negatives, when you add them up, they become a bigger negative, which is negative 6 over 10, and then I can reduce that to be negative 3/5. So that's my slope. Now to check that, what I can do is I can plot the line. So I graph the 2 points and connect them with a straight line. And if I wanted to, I could just count rise over run. So my rise here is down 1, 2, 3, 4, 5, negative 6, run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you take negative 6 over 10, that reduces to negative 3/5. So notice that it's the same if you use the formula or if you use the graph. Our next problem, let's label our x1, y1. And I'm going to rewrite my formula. I find that if you continue to rewrite your formulas, you'll have them memorized by the test. So I have 2 minuses in the formula. And then I'm going to come and grab my y2, which is 4, minus, because there's a minus in the formula, y1, which is also 4. 2 minus, which is in the formula, a negative 3. So in the numerator I get 0, in the denominator, add a line, change the sign, and I get 5. So my slope is 0 using my formula. If I come back and plot my points, negative 3, 4, and 2, 4, still that's a horizontal line, and my slope is still 0. And our next one, x1, y1, x2, y2, and my slope is y2 minus y1 over x2 minus x1. So that gets me 2 minus, because there's a minus in the formula, and then y1, which is 5. In the denominator, I have x2, which is 1, minus x1, which is 1. So negative 3 in the numerator over 0, and anything divided by 0 is undefined. So this slope is undefined. Now I know what undefined graphs look like vertical lines, so when I plot these 2 points, I'm really hoping that they are in a vertical line from each other. So 1, 5, and then 1, 2, and sure enough, that is a vertical undefined slope. So when we have these zero slopes and undefined slopes, we're going to be using them quite a bit, and so I have a little mnemonic device to help you with those vertical and horizontal lines, which we're going to call special cases. It's called HOI VUX. HOI stands, the H in HOI stands for horizontal, horizontal lines have, this O is for 0 slope. I know it's an O, but it's also a 0 for this one, okay? So write 0 in parentheses. And the equation looks like y equals some number. So when we start writing equations, we'll need to use this y equals equation, and also when we're graphing, so that'll be helpful. Now VUX has some meaning as well. V stands for vertical lines, have an undefined slope, and their equations look like x equals some number, like x equals 3. Okay, so Hoy VUX will help you remember that. So if you ever have a zero slope, you know that's a Hoy, or horizontal line. If you ever have an undefined slope, you know that's a VUX or a vertical line. Next, we're going to use a point and a slope, and we would like to get a graph. So the order in which you're going to do that is I want you to plot the point and then use the slope to get another point. Think the numerator is your rise and the denominator is your run. Okay? Then I want you to connect your point with a straight line using arrows on either end. So we have m equals 3/5 through the point 1 comma negative 2. So I'm going to graph the point 1 comma negative 2 first. And then I'm going to use the slope to rise and run. So I'm going to just put a little reminder that the numerator is the rise and the denominator is run. So I'm going to rise up 1, 2, 3 and run 1, 2, 3, 4, 5. And that would be good enough for my line. Now I could go down 1, 2, 3 and left 1, 2, 3, 4, 5, and that's also going to be on my line as long as I'm repeating the same pattern. For the next problem, I'm going to start with my point 1 comma negative 2, and then I'm going to do my slope, which is rise over run. So my rise is going to be 0 and my run is going to be 1, because any whole number can be rewritten as a fraction by putting over 1. So I'm going to rise nothing and run 1. Rise nothing again, run 1. I can do that as many times as I want, and I'm going to get a horizontal line. Or you could just know that 0 is going to be a horizontal line. And then our last problem, we have a 1 and a negative 2. That's where I'm going to start my point. This is m is undefined. So undefined, you know, is a vertical line. So you can just go ahead and do the vertical line right now if you know that. Another way you can think of it is any number divided by 0 is undefined. So I could go up 1, 2, 3, 4, 5, 6, 7 and write 1, and then that would still be my line. Now it could be any number over 0. I just happened to pick 7. But that is how you're going to do those problems.